A farmer is growing winter wheat. The amount of wheat he will get per hectare depends on, among other things, the amount of nitrogen fertilizer that he uses. For his particular farm, the amount of wheat depends on the nitrogen in the following way. Y equals 7000 plus 32n minus 0.1n squared, where Y is the amount of wheat produced in kilograms per hectare and n is the amount of nitrogen added in kilograms per hectare. How much wheat will he get per hectare if he uses 100 kilograms of nitrogen per hectare? So N is the amount in kilograms of nitrogen that he uses for each hectare, and Y is the amount of wheat produced in kilograms in each hectare. So to find Y, we plug 100 in for N. So we have 7000 plus 32 times 100 minus 0.1 times 100 squared. So we get 2800. And since Y is also in kilograms per hectare, we have to write down these units. Find the amount of nitrogen that he must use in order to maximize the amount of wheat produced. Now, to answer this question, I want to show a graph of Y against N. Now, Y is a quadratic function of N. The graph of a quadratic function is U-shape. It could be an upright U-shape like this, or it could be an inverted U-shape. It has just one turning point. So if it's inverted, it will continue on like this, as indicated by the arrows. You won't see it turning back. If we look at the squared term, we see that it's negative. This is the squared term. The squared term is usually written first. It's written last here, but that doesn't matter. We see it's minus 0.1n squared. So that tells us straight away that the quadratic graph is an inverted U-shape. Not only that, but we know that it crosses the y-axis at 7000. It's always well worth plotting this point here. We plot this point by letting n equal 0. When n is 0, y is 7000. We just get this number here. It's very easy to plug 0 in for n. Basically, these two terms will disappear, and we're just left with this term. So the constant term in a quadratic function is where the graph of the quadratic function crosses the vertical axis. Now we are interested in the value of n, that is the amount of nitrogen, which gives us the maximum value for the amount of wheat produced. So how do we find this value n? Well, this is where we can use differentiation, because at this particular value, whatever it is, the slope or the tangent to the graph is horizontal. And if the tangent is horizontal, it means that the slope is 0. The slope of the tangent is 0. But what is the slope of a tangent to a curve? We've seen before that the slope of a tangent to a curve is the derivative of y with respect to n, and must equal 0. So basically, we solve this equation to find out what this value of n is. So let's get dy dn and put it equal to 0. If we differentiate 7000 with respect to n, we get 0. That's just a constant. When we differentiate 32n with respect to n, we get 32. When we differentiate minus 0.1n squared with respect to n, we multiply the power, which is 2, by minus 0.1 to give minus 0.2. Multiply by n to the power of 2 minus 1, which is 1. We put that equal to 0 and we solve for n. So n equals minus 32 divided by minus 0.2. That's 320 divided by 2, which is 160. And as we saw, the units of n are kilograms per hectare. I'll just write H for hectare. So when n is 160 kilograms per hectare, then we get the maximum yield of wheat. In the next question, we want the maximum possible amount of wheat produced per hectare. So basically, we want to find the value of y, which corresponds to n equals 160. So we want the coordinates of this point. We want the y coordinate of this point. Well, this is a point on the graph. So if it's a point on the graph, it has to be satisfied. The equation of the graph has to be satisfied by it. So we just plug 160 in for n into the equation of the curve, because we're looking for a point on the curve. So we get 7,000 plus 32 times 160 minus 0.1 times 160 squared. That gives 9,560 kilograms per hectare. So we can call this value y max. The farmer's total costs for producing the wheat are 1,300 euros per hectare. He can then sell the wheat for 160 euros per ton. He can also get 75 euros per hectare for the leftover straw. If he achieves the maximum amount of wheat, what is his profit per hectare? So we're looking at the production costs for just 1 hectare, and they are 1,300 euros. He sells the wheat for 160 euros per ton. Now, what is a ton? Well, a metric ton is 1,000 kilograms. So we want to see how many metric tons are in 9,560 kilograms. This is the yield of wheat. This is the maximum yield of wheat, and we're assuming that he achieves this maximum amount of wheat. So we have 9,560 kilograms divided by 1,000 gives 9.56 tons per hectare. The return that he gets for 1 ton of wheat is 160 euros. And we're interested in the return that he gets for 9.56 tons of wheat. So this is his yield. He's achieving the maximum yield or amount of wheat, which is this here. This here is 9.56 tons, or 9,560 kilograms. He also gets 75 euros per hectare for the leftover straw. So we add on the amount that he gets per hectare for the leftover straw, which is 75 euros. So these are the returns for the 9.56 tons of wheat per hectare and 75 euros per hectare of straw. So to find the profit that he makes per hectare, we take the returns per hectare and subtract his production costs per hectare. And if we do that, we get 304.6 euros.